Today we're going to be doing the Unit 3 study guide so that you will ace your Unit 3 test. So what subatomic particles do atoms gain, lose, or share when they form chemical bonds? This is the unit we've been talking about, chemical bonds. What are these things right here? The outside of the atom, those would be the valence electrons. Count the atoms in one molecule of hydrogen sulfate. I've got 2 hydrogens. I have 1 sulfur. There's no coefficient, no subscript, and I have 4 oxygens. Count the atoms in 2 molecules of sugar. So this 2 distributes here. I have 12 carbons. I have 24 hydrogens, and I have 12 oxygens for a total of 48 atoms. How many oxygen atoms are in 1 molecule of lithium SO4? So I've got, let's see, oxygen only. I go 2 distributes at 4, so I would have 8 oxygen atoms. So classify each of the following as a chemical change or a physical change. We have notes on that if you'd like to go back and refer to them. Keep in mind, though, that a physical change is a change in shape, state of matter. Like state of matter, when I say that, I mean that it goes from a liquid to a solid. Like if you're, like if you're freezing something. And a chemical change, as we would know, that if it's changing at a subatomic level. Okay, so breaking a stick, that would be a shape change, that's physical. Burning a match, I would definitely notice an odor on that one, so that's one of my 4 signs, so that is chemical. Metal rusting, chemical. Tarnishing metal, that's when the silver would change, that's chemical. Melting ice is an example of changing from a solid to a liquid, so that's a change of state of matter. That is a physical change. So even though there's a change of temperature, you might think, but it's not a surprise when it's not a chemical. It's still H2O there. Baking a cake, chemical. Roasting a marshmallow, chemical. Mixing lemonade and water, physical. Cutting hair, physical. Size, shape, or state of matter, physical. Water evaporating, change of state of matter is physical. Precipitate formed is one of my chemical signs, so chemical. What is the name of the chemical reaction when a base chemically reacts with an acid? We just studied that. That is neutralization. Blue copper sulfate and magnesium ribbon yields magnesium sulfate and copper precipitate. This is represented by this chemical equation. Use these words that are underlined above to answer. So what are the reactants? The reactants are on this side of the equation. So my reactants are copper, sulfate, and magnesium. The products are then magnesium, sulfate, and copper. What does that plus sign mean? It means that they are reacting together. They're adding. The arrow yields. Is it a balance? Well, let's check. Copper, sulfur, oxygen, magnesium. Copper, sulfur, oxygen, magnesium. And I do them like this so I don't confuse them. So let's see. No coefficient, no subscript here. So 1 copper, 1 sulfur. That subscript goes there. I've got 4, 1 magnesium. Coppers 1, sulfur 1, oxygen 4, magnesium 1, so yes. So if I combine steel wool and copper sulfate in a baggie and a color and temperature change occurred, copper and iron sulfate are formed. What are the reactants? They're this side of the equation. They're on the left side. So what I'm adding is the steel wool and the copper sulfate. I'm going to actually do that. That's copper sulfate. You can write the words if you prefer. What are my products? My products here are the copper and the iron sulfate. What are the 2 clues that a chemical change occurred? Color and temperature change. So I've got color and temperature change. I wonder if it was an endo or exothermic reaction. The mass of the reactants will be the same because of the law of conservation of mass. And that actually is a multiple choice, which is right here. Okay, let's look at what we have here. What number should go in the line? So first thing I'm going to have to do is figure out what I've got on my reactant side and what I have on my product side. So here I've got my hydrogens. I've got a subscript of 2. So I'd have 2 hydrogens. Subscript of O is 2. Oop, light went out. Over here, my hydrogens, I have 2 times 2, which is 4. This 2 distributes there, so I have those 2 plus these 2, so I have a total of 4. So no, these do not match. So I would put, let's start with my hydrogens. If I put a 2 here, let me go back and redo it. So 2 times 2, I'd now have 4. 2 times 2, I'd have 4. Now they are balanced. So 2 should go there. Okay, so now we're looking at the grams. So this side must equal this side. So if I add 53 and 27, I get myself 80. So 62 plus what is going to give me 80? So what I could do there is go 80 minus 62, and that would give me 18. So I would have to have 18 grams of the copper. If I add that to the 62 grams of the magnesium sulfate, these would then be equal. I'd have 80 grams on both sides. Okay, let's look at acids and bases. An unknown liquid turns pH paper blue. It tastes bitter, and it's corrosive and is slippery. What's the unknown substance? Well, I know from my notes that if it's slippery and corrosive, it's a base. And I know in the lab that if it is a litmus paper, if it is pink litmus paper, turning it blue, it must be a base. Neutral would pretty much all say the same. Combustible means that it would burn easily. It doesn't mention anything about that, so that's not it. Endo and exothermic. Endo, the heat is leaving. Exo, the heat's coming in. So a hot pack becomes warm and it releases energy. It increases the temperature. That must be an exothermic reaction. A cold pack becomes cooler. What do we call that? When it absorbs energy, it decreases temperature. So a graph, it would look like this. This graph, it would look like this. This would be an endothermic reaction. So here's another example of law of conservation of mass. The reactants in a chemical reaction have a total of 150 grams, and it makes a solid and a gas. The gas has a mass of 100 grams. What does the solid have to be? Well, if they have to be equal, I would add 50 to 100 to get my 150 grams. The chemical formulas for acids begin with hydrogen because acids have a high concentration of hydrogen ions. The chemical formulas for bases ends with an OH, which is negative, because bases contain lots of hydroxide ions. So let's look at these and which two of these chemical reactions represent acid-base reaction. So from my notes in the lab, I know that acids are going to start with an H and bases are going to end with an OH. So I'm looking for something that has that, and they'll yield a water and some sort of a salt. So, oh look, OH and H yields a water and a salt. That's one of them. Let's see, this is not reacting with anything, and so that's not it. CH and O2, nope, that doesn't have an H and OH, so that's not it, nor does it make water. Oh, look, here's an OH, here's an H. So this is my base, this is my acid. It makes water and a salt. That's my other one. 4 clues that a chemical change has occurred. My class should know this. We've got color change. We have a change in the temperature. Gas is formed. In a gas, 2 signs of a gas, I've got bubbles, and I've got an odor, and a precipitate is formed. Something new or chunky is there. Here's my pH scale. Label this where I'd find an acid, base, and neutral. My teacher said A comes first. I label this 1, 7, 14. So the earlier part here, this is my acid. The closer I get to 7, the more neutral. This is my neutral, like water, blood. And these are my bases. This would be a basic anywhere here. The closer to 7 it gets, the less strong it is. So a strong base is over here and a strong acid is over there. We are almost done. 1 page to go. What chemical bond is formed when, this is a long time ago, when a calcium, which is a metal, loses a valence electron to chlorine, a nonmetal? So that would be, if I got a metal and a nonmetal, that is ionic. So what chemical bond is formed when the valence electrons are shared? So with fluorine, another nonmetal, and hydrogen, a nonmetal, that would make a covalent bond. Okay, so here I have compound, element, and a mixture. When you have this test, it's going to look, the study guide is going to be a little different. Compound, 2 or more chemically combined. Mixture, not chemically combined. Element, it's just a single, it's on the periodic table. It's not joined with anything. When you have your study guide, it's going to be more space for you. So let's think about this. So check mix. Check mix. It is not chemically combined. I can figure out where the peanuts are and the Chex Mix is. What else do we have in there? Pretzels. So that would be a mixture. Gold. It's on the periodic table. It's got to be an element. Carbon dioxide. Those are chemically combined. That must be a compound. Iron. That is on the periodic table. That is an element. Salt. Chemically combined. That is a compound. Pepperoni pizza. I can pick the pepperonis off. The new substance isn't formed. That is a mixture. So now let's look at visuals. I'm going to start with this one. This one's the easiest. That's an element. It's all of one of the same thing. This has a bunch of different things and they're not chemically combined together. So this is going to be my mixture and this is going to be my compound because they are chemically combined and there's 2 or more. I've got these 2 little dots and then the 1 big one. So here I have more definitions, so I'm going to change this. So you'll just have this down here. So I'm going to add mixture. Matter, it's a good one to know, is anything that has mass and volume. You could also say takes up space. Element is something you find on the periodic table. Compound is 2 or more chemically combined elements or molecules. And a mixture is not chemically combined. So that is your study guide. Good luck on your test. I'll see you in class.